Hi there. In the next three episodes on the channel, we will look into form finding. In this episode, AJ Scheuble from DHK shows us how to use Kangaroo in the making of a complex form. Towards the end, Bio from BPS Architects shows us how to use the Dynashape package for Dynamo, just very basically. Thank you. Enjoying the episode.
Okay, cool. Let's get going. What we're actually finally going to do is going to have like a tensile structure, and it's going to be a mesh structure. In the beginning, I mean, I was quite reluctant to start playing with meshes because I thought nerves was the ultimate in modeling. It's very, very precise geometry and simple inputs. But it seems like meshing is quite powerful, especially for what do you call it, like manufacturing and when you have to create cut lists, stuff like that, and nesting, all that type of stuff. So this one is more mesh exercise. And then, the steps is, first of all, you just define a point. And then from the point, rectangle component. And I mean, all of these are fairly simple components, so I'm sure you're following along quite nicely.
Yep.
That's actually the final thing we'll get to. So let me just switch it off for a moment, and I'm just going to sort of select one thing at a time. And it's, to my mind, it seems like a bit of a roundabout way of achieving this, but that's often the case with this computational design, right? You have to build a logic, and it's not always logical to me, but anyway, so it's the idea is to get to the point where it is logical. So we from that point we created a rectangle, and I guess the idea of starting with a point is just that you can move it around if you want to move the overall script around. It's like most of it's live, so if I move it, it's probably going to take quite a bit of computational thinking or time on my side. But yeah, there you go. So you can move around quite easily. I mean, you're very familiar with those type of concepts. For me, it's still fairly new, So okay.
You're not that new anymore.
Yeah, that's true. It's been a little bit more than a year now. But yeah, I just feel like a novice whenever I see what these damn guys are up to, and then once you've defined the points, there's the Voronoi thing, which is typically a bit overdone in the industry. But it uses those points to create the Voronoi pattern.
Oh yeah.
And then usually on other sort of tutorials I've seen, they generally just use the same rectangle that they use to populate with points. They just take the same rectangle and create a boundary around that geometry.
Oh, okay.
And if you do that, you'll see that the Voronoi shape actually gets trimmed. So if I click on it now, it's just going to be a neat, clean one. But in this instance, I actually did it slightly differently, and I'm still trying to figure out why. But they actually took the Voronoi and then just trimmed it. They used the trim component, which is built in, but they decided to do it separately. Trim with region. So I'm not seeing the trimmed one. Seeing too much at the moment. Okay, it's because it's showing inside and outside curves, and we only want the inside curve, which is, as you can see, my computer is really slow today, slower than usual, actually.
Yes.
I think, let me actually just stop one or two of these.
That's a long graph.
Yes, don't worry, it's actually not that long, but I'm just going to deactivate a few things so we don't have to spend hours and hours just panning or scrolling, So, I think it should be a bit more responsive now. And like I said, I don't have the most powerful computer at home. So, and once you've got that Voronoi pattern, it's actually just a collection of curves. Which we then explode, and as soon as you explode in Grasshopper, it actually creates aligned segments, and it also creates the vertices, the points. I don't know how much you've played around with this, but that's quite
the cool thing about Grasshopper is that those outputs, it's usually not just one output. With Dynamo, I mean, there's some nodes that have more than one output, but usually it's
Yeah.
just one output. You
Interesting, eh?
to get
Yeah.
those vertices, I'll have to get like a node that says curve.endpoints, for
Ah,
instance.
okay.
So, but
Yes,
with
yeah.
this, or I have to explode, I have to get a node that is for exploding geometry. Um,
Uh,
but
okay.
Grasshopper is cool because you have all those options.
Yeah, I mean, obviously this component could give it independently as well, but like you say, some components just give you more than one thing, which
Yeah.
is great. And then from there, we just extracted the midpoints. So if I just show both of them, if you, all of the segments with their endpoints, we're also extracting a curved middle point.
Mm.
You could also use that evaluate curve and put it at zero point 0.5, but I think this
Yeah,
one is
yeah, yeah.
cool. And then because they're lines on top of each other, we just call the duplicates. So we just end up with one point on either side.
Okay.
So let me just see, this should be 18 values. Yeah, so the 18 points. And then, yeah, the segments, we gonna try, what are we doing with the segments? We're doing something with them. Let's find out, okay, we're offsetting the segments. And once again, I found this interesting the way it was done. So we've got the lines, and then we do an offset to both sides.
Mm.
So this whole script at the bottom, I just tried an alternative way, but they basically used endtwine. So they took a number 2, which is positive, and then they used the same number but a negative component. So it's +2 and -2, and they combined the two and then fed it into the component. So if it was just 2, it would have obviously just gone to the one side, but
Mm.
because you entwine the two numbers, it goes to both sides.
Okay.
Um, and then, I mean, like there are other components you could have used. Like I tried Weave as well, just to see if it throws out the two numbers, which it does. And the grafting, I think you're probably familiar with that already in terms of Grasshopper. I mean, I'm no expert and I'm still getting my head around it, but essentially what grafting does, it creates two tree branches. And whenever the output is used, the component will compute both of these. You know, if it was just a list,
Okay.
it might not do it. So that's the
Okay, so
thinking behind
is
it.
that graft doesn't mean mapping. Like
Yeah,
you apply the that kind of function to both inputs or something like that.
yeah, it's more about the output is instead of a list of just two items below each other, which would do something else. I'm just gonna show you something else. The param viewer is quite useful when you're starting out, just to understand things. So before we grafted it, it's one branch with two values in it.
Okay, yeah.
So, and I'm actually not quite sure what that would do if we just did it straight in there. Yeah, it's sort of, I think it probably just chooses where it does what type of thing. It's not very rational. But if we, after you've grafted it, you'll see it will become two branches,
Mm.
and each one of the branches has one value in it. So it's two
Okay.
branches, and each one has one value. The one is -2, and the other one is +2. So if you feed this into the offset curve, it'll calculate both branches. So it'll first calculate at -2 for all the curves, the entire list,
Mm.
and then it'll do a +2 for the entire list. So it's just to make sure that it goes both ways, essentially. Yeah. But grafting is that, I mean, the opposite of grafting is when you flatten it, and let's just see if it allows us to do that,
Mm.
which is where we just make it into one branch, one list again.
Yes.
And, yeah, so that's obvious.
Yeah.
So there one branch, and the branch is 0, and there's two branches, so it operates twice.
Mm.
So does Dynamo also have the flatten, or is it some
Yeah,
other way?
Dynamo has a flatten, yeah. So but
Yeah.
with the way grafting works in Dynamo is there are
Yeah.
things called levels.
Oh,
It's kind of more complicated, you know?
yes.
There's things
Yeah.
called levels. So you have cases where you've got lists that are, you know, of different lengths, right? So
Yes.
maybe
Yeah.
there's like a list that might have 4 levels of nesting, and another list
Yes.
might have 3 levels of nesting. And you know,
Yes.
you need to match those lists sometimes. And to
Yes.
match those lists, you need to be able to pick, you need to look at the whole list and pick what level you precisely want them to match at. So I might want the level 2 and level 3
Yeah.
to speak to each other. So on the node itself, you have to say 2 and 3 need to talk to each other. Um,
Right.
so it's that it takes getting used to. Yeah, it's like
Yeah, it would. That would confuse me even more. Even this basic stuff is hectic for
it
me.
really is confusing. Yeah.
Confusing. Yeah, no good. Um, yeah, so basically just coming back to this one with the offset. So because there were 18 curves before, we've got 18. Well, Grasshopper always starts at 0, so it's confusing in the beginning. You think there's 17 curves, but they're actually 18 because you have to
Yeah.
count 0 as well.
Yeah. Just
Um,
one comment.
yeah,
Like
yeah,
all programming in general starts with
mm,
0.
yes,
So
okay.
even Python
So
and Dynamo does the same thing.
same thing, so
Yeah.
you're quite familiar with that. It's, yeah, I mean, it's kind of obvious that it should, but in the beginning it really threw me because sometimes you
Same.
just think that the lists are equal lengths and then they aren't, and things like that. And Grasshopper is also very fussy like that. If your data trees or your data lists don't match when you're trying to work on both together, then it just doesn't work. Okay, and then basically what this did is, okay, let's just get this into the graph map as well. So basically now instead of 18, we've got 36 branches, each with one item in it. But if you look at the data tree, there's 0 to 17, and there's on branch 0, and then there's branch 1, which is 0 to 17 as well. So shift path, which sounds like it's something like what you may have to do in Dynamo as well, just pushes those two lists together. I mean, that's how I understand it. I'm sure it's much more scientific than that. But basically, it takes the list 0 and the list 1, and whatever was the item 0, and both of those lists get combined together. So then you can work on those in pairs of all the curves.
Yeah, that's called transpose in Dynamo.
Is it? Okay, great. Yeah. And then once you've got those pairs, you can split it up onto the two separate sides. So if I had to do a curve, the one at the bottom, that's going to be one side, and the other one is on the other side. So if I click on both, it's both sides of that, or of the offset. So if I go back to the original, but I think you're following right. It's the segments which has been offset to both sides. So that's cool. And then once you've done that, what they did here was interesting. There's a connect curves one. So we've got these pairs of curves, and what the connect curve did is it just closed it up. And I would never have done this or thought of this. And what's also interesting is continuity. I'm sure you're familiar with that as well. So in Grasshopper, your continuity 0 means that your curves are touching. The continuity 1 means it's tangent. So if two curves meet, then they become tangent. And what you call a continuity 2 would mean the curvature is the same for both. So actually, let's try that. It should round the edges. If we do it as 1. There you go. So continuity 1 is tangent. 2 should look probably very similar, maybe just a softer curve, I guess, or flatter curve, yeah. But by using,
sorry, I say we've never seen that in Dynamo. I think I would have to apply like a fillet. Or maybe I'm wrong. I'll have to apply a fillet to those edges, but that is very cool. Yeah.
Yeah, I'm sure there will be some way of doing it, but it's I find that's the funny thing about Grasshopper. These principles are so simple once you know them.
Yeah.
But then for me to build it from scratch, it's quite a different mindset or way of thinking, right? And then the next step is a typical Boolean exercise where more like Illustrator or something where they're just all combined, so the individual solids just get combined like that. So yeah, that's why I felt it's quite a roundabout way, but that's how the base geometry was created. And from there we start building it up.
That is so crazy. I can't. How would I do this in Dynamo? Jeez, like I would have to make it a solid or something. then find the bottom face. I can't.
And
I don't
extract the
know.
bottom face and get an
Yeah,
outline, something
yeah,
like that.
yeah.
Yeah.
I don't know how I'm gonna merge shapes like that in Dynamo. It's not possible.
Really, eh? Yeah.
Uh, yeah,
Once again, it probably is, but we just don't know. But
yeah,
yeah,
yeah. But yeah, maybe it's possible, but that is crazy.
yeah. And I don't know, you're fairly advanced. Well, it sounds like you're a very advanced user, actually, so you probably would
Yeah,
have known if it was there. But
I
yeah,
yeah I know a lot of Dynamo already. Yeah, so
yes.
something like this is like nope. You would have to figure out the math for it because I was trying
Yes.
to do a generative design graph that does something like this that extrudes
Mm,
the earth edges
okay.
at different distances,
Yeah.
right? And that
Okay.
was such a mission to do.
But
Which
was it worth it in the end?
yeah,
Because
it's gonna be worth it. It's still an
yeah,
ongoing thing, but yeah,
because
it's
I find that's also something I struggle with sometimes because I mean just doing this stuff is actually interesting and fun, right? But then not all of it's actually useful, and especially I heard one of the Scandinavian guys from is it Link Architecture or something? He also said the other day, you know, when you're implementing for your office, you have to maintain a balance as well because if it's too advanced, whatever, nobody can use it,
exactly.
or there's resistance. But anyway, it's I'm going on a rabbit trail now. It's
Yeah, let's
yeah,
go.
trying to do productive stuff with it and not get lost in the tech and the excitement of it.
Mm,
Okay, yeah. So next step was so we split it up into segments again. This new shape that we've got, and it shows once again it shows vertices and the segments, but we're only working on this on the actual segments. Um, there's a flatten command just to make sure we're looking at all the segments in one go
mm,
to evaluate the lengths. And then based on the lengths, this is just rounding it off to a certain fraction. But we also then have an equality, what do you call it, almost like a mask or a filter, which we use then to dispatch the segments into two categories. And the equal to, and I'm sorry, I'm scrolling around quite fast, so just let me know if it's getting a bit confusing. But essentially, right in the beginning, our offset was a value of 2 plus 2 and minus 2,
mm.
which means like those curves are 4 units apart. And that's what we're doing here as well. We're taking 2 times 2, so it's 4. So all the segments that are 4 units long will be part of the equality, which we're actually not using. Let's actually just look at it quick. Those will be the end curves. Why is it not giving me? Oh, no, I have to dispatch it. Sorry. So I'm clicking on the wrong side. Once it's dispatched, it will split it up. So these are the end curves. Sorry, I was just a bit
Okay.
earlier. So, this equality is also like a Boolean operation, I guess. It tells you which ones are equal and which ones aren't equal to it. I suppose if I did this, it'll just swap it around. That one will become the end units. So once again, very simple again. And that's just a tool to split them based on the lengths. So these are the actual edges, and these are the endpoints. And then, yeah, the person doing the actual tutorial just added some dots and some points so you can see what you're looking at. The blue ones are the center points of the central curves, and then the yellow ones are the center points of the pairs of curves that's linked to those center curves. And then, yeah, that is basically it. And then a really cool component, which I didn't know about before, I knew about closest points, where you take a whole cloud of points and then see how far they're away from one point. But this closest points, what it does is it can give you 2, or it can give you any number of points that's closest to center points. So, which one is the center point? Yeah, the blue was. So this component will tell me, the 2 nearest points to each one of those blue dots, which yeah, it's once again so simple but so powerful. So immediately we can select those actual curves. You see, so these are all the curves, and based on that equality, this is where it becomes more like lists, where I still get a bit lost at times, but essentially we just, what are we doing? Let me just think about this now. We are Okay, we're trying to create a loft. Okay, what we're doing is we getting the two endpoints and the center point and we're combining them together. That's why we're inserting items here. That one probably goes way back to all the center vertices. Yeah, that we use to generate the script. And then let's just go back to this side. So we're doing a loft, and so each one of these is a separate loft of three curves.
Okay.
And then from the loft, we just change it into a mesh. And like I said, it's interesting for me to see how powerful meshes can be. I always thought it's more just for the rendering guys to model stuff up and do all of that. And then, so go ahead.
Oh no! I'm saying meshes are very cool.
Yeah.
Remember that Baha'i temple project I
Yes.
worked on?
Yeah.
Those curved surfaces.
Yeah.
I had to flatten. But to flatten them, I had to create quad meshes.
Okay, got
So
it. Yes.
when you do the quads, then you can then give it to someone who uses Maya or something to create a flattening of it. But there's also a package on Dynamo, which I use, Dynamo Unfold, which can then flatten the actual geometry. And then you can then draw whatever you want on that flattened geometry and re-wrap it onto the main surface. That's how that workflow was. So yeah, meshes are very like super
powerful like that. Yeah. Just on that, it's interesting because I would have thought if it's a quad, it's got 4 points, right? And if it's a curved surface, it means like if you flatten it, it might deform slightly. Unless I misunderstand, because what I did another tutorial the other day, and they triangulated the surfaces because with a triangle, it's always a flat piece that you're going to get, that you can assemble again. But it's interesting. So yeah. And then, excuse me, let's clear the throat. So then I'm assuming it's because it was separate lofts, which created separate meshes, even though we don't see the ISO curves. I don't know why my Rhino doesn't show that. We join them and we weld them just to make it one thing. And then the refine, I think it's probably almost like a subdivision. I'm not 100% sure, just to get a finer grain of it. And then naked points, these are...
Oh, geez.
Yeah, so this actually just breaks it up into different points. And I think the reason was just to capture the endpoints, because what the script does then, it uses those points as anchors, and then it runs a physics component on it, which I'll show you now, which really stretches my old little computer. If I could activate all of these guys. So, why is it giving me hassles now? That's probably the thing that's not on. Okay, that's why. You see, so, and this just breaks it up into all the vertices, and because it's lists, you can still work with them, and I think we reconfigure them into... No, I think that's probably as far as it goes. I thought it was reconfigured into quite all surfaces, edge surfaces, but this one I think stops here, mesh edge. And then this is just all inputs for the physics generator. And then I'm just going to run it now. Like I said, it's probably going to take a moment or two.
So oh my, is the solver, is it a package you install?
Yeah, so it's called Kangaroo.
Kangaroo, okay.
Yeah, so it's a plugin that you need. But I'm just going to run it again because it's actually so cool just to see it happening. And I think I'm going to just switch off all the other crap as well because it's there's so much layers of information. And that's the other interesting thing. Grasshopper used to be called explicit history because you build on the history, and that's how you actually create geometry. So. You can see it actually. I don't know if you saw the movement.
I saw it.
Yeah, so every time you click on the button, it actually does a calculation for you. And you can see it's actually still running, it's refining it based on values, physics.
Can you pull the vertices and make it bounce in Rhino, or how does it allow you to do that?
Yeah, so I mean, I'm not sure exactly how it works, but essentially, I think once you bake it into Rhino, obviously it will be static. This is more like yeah, the preview. But yeah, it literally takes a flat surface and it applies loads to it and it pushes it into that shape until it settles, based on tensile type of physics. So it's yeah, and I'm sure there would be very interesting ways of using this. I just yeah, I wish I knew how to do all of that type of stuff. I'm just gonna leave some of it on now so it's a bit easier to see. But yeah, I don't know if that answers your question, but
No,
directly in Rhino, I don't think you'll be able
yeah,
to animate anything or
yeah.
something like that. Yeah, so from that, this was, I'm not quite sure what I was trying to do up top there, so let's just ignore that. Um, and then there's mesh topology. It gives you the directions, the mesh. Let's switch some of this stuff off again. Maybe I should deactivate it actually, so we don't. Oh no, it needs to be activated. I'm not going to show it. Let's just switch off the preview, switch off the preview. So yeah, this breaks down. It looks like it's the directional. So it splits the mesh up into curves in the one direction and curves in the other direction. And then there's a plugin. Guess what it's called? Stripper. So, and I don't think there are many components in it, but one of the components is to strip via the directional. So we're basically taking that mesh and we're stripping it with that curve. And then, yeah, so it splits it up into all these separate ones. And this, I don't want to call it a gimmick, but it just shows you actually what has happened there. So let me just hide this. So it just gives colors to the
Geez, that's cool.
different
That is
strips.
very
No, it is fun, eh? Yeah. And then, yeah, and I mean, obviously, this in itself is not that spectacular, but I mean, if you start thinking of use cases and if you create it, I mean, I'm sure you can do amazing things with this. And what I really enjoyed about this one, which is starting to look like it's international architectures, they've got this thing where basically you raise the center point, or you raise, yeah, I think there's probably, each strip has got the sides and then the center, or it's the edge of the strips. I'm not quite sure which component or which part of it is, but it starts folding it, because you're lifting the vertices, so you start getting this serrated type of look to it, which is, yeah, I don't know, it's just, I find it super funky, cool type of geometry to play with, yeah. And it's actually relatively simple to get to here. I mean, it looks like a fairly long script, and I guess it is, but it's quite a few simple steps, and before you know it, you've got all these surfaces doing these amazing things. And then, yeah, I don't think I took it much further than that. Here it gets, once again, a little bit complex for me. What did we do here? I think we applied some more colors. This is the final iteration of it, but this, also really slowed down my computer. But yeah, that's what I thought I'd just run through this evening, because I didn't have my adaptive components ready, so I thought let me show you this, just to get a sense of some mesh workflows in Grasshopper.
That is very cool. Yeah.
Yeah.
No, can you pan around on Rhino?
Yeah, sure. I'm just going to see if it allows me now, because I did the silly thing and activated all these components at once. But I'm just going to try pause it. This is for the moment, and then I'll just pan around. And actually, maybe let's try bake it so we get a better sense. And then we can have a look at it.
Okay.
Yeah.
No, geez, that's very cool.
Yeah.
Way cool. Jeez.
Oh, okay. What happened? Yeah, that's why it took so long. Is if you look in the corner, I had 4 tiles, and it actually just goes and applies the tiles to those surfaces, and that's why it took a while. So, I'm wondering, should we bake that one? Let's do that. There's another one. Let's see what the custom preview is. Oh yeah, this was just adding color to it as well. I mean, that's a bit psychedelic,
Jesus.
so I don't actually enjoy that. But
Wow.
that's that's just with a gradient component. You can add colors to it, and initially the colors graded from one side only, and then when I was playing around, I made the colors grade from all four sides and all that. But my computer is just battling with all of this stuff at the moment. But I'm not sure whether the colors are going to bake, so I'm just going to undo that a little bit, and then let's just go back to this one, and let's just try and bake it into Rhino and see what happens. I think it should be there now. Just try a rendered view. And, I just hope it doesn't crash, because I think I'm pushing my memory to the limit by 8 gigs or whatever I've got on my old machine. But if it's a bit too hectic, we can go back just to the plain folded one, and I can zoom. But it's I actually downloaded a course on this kangaroo physics because you can do tensile structures, you can do those EFTE type of structures, or all that type of stuff quite easily and accurately. And the structural engineers can use your data.
Yeah, that is very cool. There's a package on Dynamo.
Yes.
I wanted to try and show you, but it's been a while since I've used it. It's called Dynashape.
Dynashape.
Look at that.
Yeah. So,
that is way cool.
Yeah. And I mean, this could be many things, I guess. And then, of course, if you change the tiles, it'll look quite different again. And what I was actually wondering is if we extrude these tiles, what it would do. But I think my computer might just resist kill it. So let's just do one, see what happens. Yeah, actually, I've locked Grasshopper. I think it's probably going to do too much. But let's some of these. But I mean, you get the idea, and you can change your patterns and all that. So you can do some metaverse stuff if you wanted to. And then, and if I had a stronger computer, I could have taken this whole mesh or surface and given it thickness, and it started working a bit more. But I'm not going to attempt it right now. So let's just close all of these guys, and let's see if we can activate
again. No, this is very cool. You see this?
Yep. Wow, that's pretty cool. Okay, so it looks very dynamic, like everything's moving.
Yeah, this is a package called Dynashape. So it's also you can also do tensile structures with this.
Okay.
But this one is Dynashape comes with Dynashape and Dynaspace. So let me show you here. So
Dynashape. How do you remember all those words that are almost pretty much identical?
There's so many. Yes. Look at all these damn.
Dyno this, Dyno that, Dyno, Dyny.
Yeah. So this was written by a computer scientist. So Dynaspace is for space planning. Dynashape is it's like the kangaroo you just showed me for all those tensile.
Yeah. So form finding type of thing.
Yes, I'm going to try showing you one of the Dynashape ones. But this is Dynaspace. So basically, you can have a bunch of areas, a bunch of basically functions in your building, and then you can say what the square meterage is and what the proximity of all those basically how close you want all those spaces to be, right?
So it's almost like a bubble diagram.
Diagram, and you can put an area, which is this boundary over here.
Yes, yeah.
And then if I come in here, you can see now I can actually start to move things around. Yes. I'm not really sure I haven't really found a good use for this yet. But what I was thinking is we could use this for trees, for instance, So if you had certain types of planting that you wanted to cluster together and you wanted to do like a generative design study to find out what the options are, and you wanted to set the proximity of the different types of planting, it could work. But for space planning, for me, it's kind of difficult to imagine how this will really help. But you can see it's pretty cool thing, right? Like,
Very, very dynamic. Yeah. I mean,
yeah,
it's I think it just helps you in terms of your bubble diagram. It's almost like a scale diagram then, which would help, just in the beginning to get a sense of the size of your building. But I'm just wondering if it could do it over 2 floors. It probably could, if you have two polygons
yeah,
above each other,
yeah,
or more, just to get the footprint smaller. Then.
yeah, yeah. That should be possible, but I
Yeah.
haven't really pushed it further.